Welcome to another Midweek with Max. This is Rick, joined by Jeremy, Joshua, JCV, Antonio. Hey, Antonio. And of course, our co founder, Max Sanchez. So let me turn it over to Max for our weekly recap, and then we can pop right into questions.
All right, sounds good. Welcome everyone to another Midweek with Max. A couple updates on the engineering side before we get into it. I think it's a pretty limited set of questions this week, possibly also due to the daylight savings time confusion, but we'll see. But yeah, on the engineering side, making good progress on the MinerFi piece, so doing full end-to-end tests with our ZK-proof updates to the TSS library to make all of the key generation, key resharing ceremonies happen on chain and be fully attributable. I've also made a lot of updates to the veHEMI contract or contracts over the last few weeks to add in restaking, so it acts sort of like a eigenlayer or symbiotic as far as being able to use veHEMI positions as economic security to participate in various protocols on the Hemi network. So got those changes in, and we're doing some additional testing on that, probably sending that out to auditors end of this week. And let's see, beyond that, MinerFi updates to the veHEMI contracts. I think actually speaking of veHEMI, Jeremy, who's on, has been posting some blog posts about veHEMI and sort of the future economic ramp of using veHEMI as economic security for various parts of the system. So if you're interested in some of the details, you can see the blog post, I think from 2 weeks ago, roughly. And I think we'll also have some other infographics and other materials around that coming out as well in the next week or so here. Beyond that, we've been continuing to work on ZK provability. So we've been making some additional improvements to the Bitcoin indexer to be a little bit faster for the ZK VM guest program, and also add in some additional indexing for the UTXO list pagination, which we support with an HBM precompile. So good progress there. That will probably also be going for auditing in the next 2-ish weeks, somewhere in that time span. So before the end of March is the target for getting the Oxygen Bitcoin Indexer ZK proving system out to auditors. Let's see, beyond that, we did not get the pop payouts algorithm deployed last week. We will be getting that done very shortly. Not a very good reason for not getting it done last week, other than a lot of other things taking priority on the engineering side, but that is going to be done imminently, as well as we'll be publishing a Hippo with sort of a simpler version of the pop payouts V2 algorithm explained. And if you want to read that instead of reading through the documentation of the pop payouts V2 code, and we'll also be adding some documentation for that to the doc site as soon as it's live. So stay tuned for that in the very near future. Let's see, I think that's pretty much it. We've also been making some progress on the ZK proof marketplace, so stay tuned for probably sometime in the next 2-ish weeks, some limited public testing of that, at least in the beta channel. So if you want to be involved in the first wave of that, there will be some minor incentives for participating, so it's not going to be, the original testnet points program V2, but if you do want to participate and earn some Hemi tokens for helping us kick the tires on some of that, either from a UI feedback or from running the actual ZK miner and submitting valid ZK proofs to the network. If you want to participate in either or both of those, definitely join the beta testers channel to get early access to that and be in that first testing wave. And then we'll probably expand that out to the broader community to do some more tire kicking and get some more feedback prior to shipping that off for auditing and then getting that into production. We are also working on, in parallel to the Oxygen changes, updates to the HVM precompiles that fix a couple of bugs in the existing precompiles that are currently worked around with Bitcoin Kit, but making things work as expected from a serialization perspective, and also adding some new precompiles for some new data that we now have available in the indexer, things around Bitcoin fees, coin flow, looking at things like coin days destroyed, things of that nature. So more high-level statistics metrics, and then also some additional fee metrics that we're going to be adding in new precompiles for. We're getting those implemented and tested, and those will be part of the upcoming Jovian/HBM Phase 1 update. So we don't have an exact date for that yet, but as we get closer, we'll come up with a date for the testnet launch. I'm guessing sometime early April for the testnet launch of those features, and then probably mid-April for production. But again, that date is not yet set in stone. And let's see, beyond that, Pluto's exploit, we are still going to be publishing a report. Still doing some research and collating everything. There ended up being a lot more potential on-chain links of the attackers than we originally anticipated last week. So getting all those into a document, we will be sharing those shortly. And I think that's pretty much everything from major updates. So I will throw it over to Rick and we can start going through questions.
All right, sounds good. Before we do that, Jeremy, do you have anything from a marketing perspective you want to share with the community?
Well, Max mentioned that we do have some interesting veHEMI content coming out. We're talking about a phased approach for this, and there are many stages to that. When it becomes a mature part of the economic and security and governance system of Hemi, we'll see it fully deployed. We're also looking forward to producing more of our live broadcasts, so keep an eye out for those. I really yeah, I was able to surface the submarine, by the way. I think I got a better signal. So we're looking forward to having more live broadcasts. We really love to see people show up to those, and we're trying to expand the platforms on which we're making our Hemi founders available to you guys. So I hope that y'all have had a wonderful weekend, and if you're anywhere in the Northeast, try and avoid the weather.
All right. That was Jeremy with sports and weather. Okay, let's see. We have very limited questions this week. I'm guessing because of stupid daylight savings time. Um, let's see. We do not have anything regarding ZK proof, probably because that was all covered on Friday. But we can start with when will there be a VBK update?
Relatively soon, so still some parts we're finalizing on that, but hopefully we'll have more information next week to share on that. So it is
Oh,
still coming. That nothing's changed, but yeah, it has been delayed relative to other things while we sort out some final numbers and address blacklists and things of that nature. So
all right. On the topic of when OG roll, gentlemen?
I think we're targeting end of March at this point. Josh, I don't know if you wanted to chime in with any additional information on that.
So the wallet linking part is mostly done on the back end side. It's just missing some UI parts. And after that's done, we just need the Discord side of things. So I'm expecting end of March to very early April at the absolute latest.
All right. Um, let's see. When will more information on the Plutus investigation be covered? You addressed that one already, Max. Um, and you also addressed the new pop payout algorithm. Uh, hmm. Those were the questions I had in the hopper. Let's see if we have anything in the live chat. Here we go. What will be the frequency of distribution of veHEMI rewards in the future?
For the near term, we're probably targeting roughly every 6 weeks. So let's say 6 to 8 weeks, but yeah, so our last distribution, I think the next distribution will probably be in about 2 to 3 weeks from now. So end of March, early April.
All right. And oh, here's one. Um, are there any more campaigns ongoing with the OG role on its way? Yes, that will be Hemi Guild, where there will be different paths for creators, for on-chain activity, and for builders slash devs. So we actually had a call with Guild today to kind of iron out some of the potential blockers we had, but we should be squared away with that now. So we anticipate that within the next couple weeks, and they're actually going to be supporting our launch, which is going to be pretty awesome. So I would say within the next week or two, we'll have a more substantial update, imminently followed by the launch itself. And I think I just covered two questions in one. So, let me see. Uh, can Max and the team tell us how they discovered Bitcoin and blockchain?
Let's see. I think I first came across it back in late 2011, early 2012. I was actually in high school at the time, and of all things, my mom read about it in some online like general news source, not even like crypto specific, and thought, oh, wow, that sounds interesting. It sounds like something Max would be interested in. So she told me about it, and I looked into it, and basically never looked back, and have been doing crypto ever since. So yeah, kind of. She's not even in computer science or anything like that. She's a graphics designer artist, but yeah, that was. I still have no idea how she came across it, but definitely glad she did.
How about you, JCV or Antonio?
All right, I can go since that keeps us in roughly chronological order. I think so. Circa 2012, I was working on this zero knowledge online backup system, open source, all that, very cool. We kind of got to a point where we realized nobody does backups, which, by the way, as a PSA, back up your goddamn data, whatever it is, because you really should and you probably aren't. And, my boss at the time was just getting interested in, had been looking into Bitcoin. We were an OpenBSD shop, so we were trying to port, and Bitrig, which was our fork of OpenBSD, and we were trying to port Bitcoin to OpenBSD. They were not super accepting of our patches, so we just decided, hey, a good way to learn about this, and it can't be that hard. We'll rewrite the Bitcoin software and go. And it was hard, but that's how we ended up writing BTCD, and that's how I got involved in Bitcoin and all of this craziness.
Yeah, famous last words. How hard could it be to just rewrite this in a new language? Not to mention
And
the community controversy around rewriting it in a new language too.
oh my God, they had the pitchforks out. They were ready for us. We were gonna apparently the prevailing belief at the time was we were going to break the network and kill Bitcoin. Because if we introduced any bug, that would just ruin everything. And yeah, that didn't happen. Bitcoin's still around despite apparently our best efforts.
One of these days.
All right. Let's see. How about Jeremy? How about you? How did you discover blockchain and Bitcoin?
Well, outside of some endeavors to try to mine Bitcoin on a cell phone, which resulted in the phone getting very hot and not charging, um, I ended up working at a company called ETH News in 2017, where I was a journalist covering the Ethereum ecosystem. And among many, many stories in my 11 months there, I produced like 600 stories while I worked there. I interviewed a lot of people, including John McAfee, and some other like big names in the ecosystem. And eventually, I started working for several other organizations. I've worked for the Flow Foundation. I've worked for many other organizations, and I love everything about decentralized finance and the entire ecosystem built around crypto. I think it's a way to give the power back to the people. So I'm very pleased to have been working here for many years in the industry.
We have covered OG, VBK, Plutos, the pop payout algorithm, and Hemi Guild and other campaigns. Beyond that, well, I can say there is a GeoGuessr session hosted by the moderators immediately following this, and I I I think
Well,
this.
Rick, we got to plug the AI happy hour.
We do need to plug AI Happy Hour. The thing is with that, Jeremy, we need to set a time and date for it.
Well, I believe we were going to set Thursday this week, right? Thursday is going to be our AI happy hour, and we're going to firm a time up and then have an official announcement here in the Discord. So keep an eye open for that in the next few hours. And yeah, Thursday morning or Thursday afternoon, probably better, unless we want to get silly sooner.
I don't think we should drink during the morning.
Yeah, I was gonna say probably not the healthiest choice, but Thursday afternoon, join us for.
It's when is crypto about making healthy choices?
Yeah. Well,
You make a good point, but at the same time, I don't know. I don't know if we should be encouraging drinking that early in the morning. So maybe when we set our time, we aim for the afternoon.
yes. We'll aim afternoon, and we'll have a way for you guys to join that sent out on the announcement channels very soon. So keep an eye open.
Yeah, and it will follow the same format as our ZK Proof monthly engineering AMA. The topic will change. It will not be about ZK Proof every month, but it will be from the engineering side.
Does anyone know which of the commercial AIs, which one is best suited for asking what drink I should make?
I think you could ask the community.
Yeah, I mean, you don't have to ask AI for everything. You know, it's
Yeah.
okay.
Only because it's an AI happy hour. I don't normally ask AI for anything. I figured
have
that
to
would be the
make
one
a-
time to give it the chance to prove whether or not it's be good.
We're gonna have to make a mixology bot.
That's not a bad idea. I do have some more questions though. I have two actual questions before we continue talking about alcohol and AI. There'll be plenty of time for that on Thursday, I'm sure. What is the current status and timeline for HBit VM, and what are the biggest unsolved engineering challenges remaining before it's production ready?
So for HBit VM, still targeting Q2 for a production mainnet launch date. As far as remaining engineering challenges, most of it is on the ZK provability side. So that's the component we're working on with Oxygen for ZK proofs of the Bitcoin indexer state transition and the HM precompile calls. We're going to be mostly reusing as is. There's some small modifications that we have to make, but mostly reusing as is the existing EVM execution, ZK proving systems that are already out there. And then there's a couple pieces for how we're building the ZK proof upgrade system using governance. And so there's some components there that need to be built for being able to. I know I've talked about this in the past, but just as a kind of coming off of maybe all of the ZK discussions in the ZK AMA on Friday, is an interesting part we didn't really cover, which is how you actually upgrade ZK systems in production and do that securely and do that in a way that is compatible with BitVM style designs. So one of the challenges with BitVM in general, but HBitVM as well as a descendant of a lot of those approaches that other BitVM style technologies are using, is that once you construct a vault on Bitcoin with you set up the whole HBitVM transaction graph with all of the covenant emulation pre-signed transactions. One of the things you have to do is pre-configure the Groth16 verifier with basically the known parameters about Bitcoin, Ethereum, and Hemi state that it's going to validate the future ZK proof against. And so for most ZK systems in the Ethereum ecosystem, there is you have the ability to, each time you get a ZK proof of some new state update from a remote chain, you can update contract state and then reference that in the future. So if you wrote, a ZK bridge between Ethereum and Solana, for example, then, every 5 minutes, hour, day, whatever your frequency is, Solana could update its currently known, last good finalized point of Ethereum state and then validate new ZK proofs just against the delta from the last validated state to the new one with new ZK proof. And one of the issues with, and also obviously if, the Ethereum protocol changed, then governance on the Solana contract side could go and update the image ID of the ZK verifier that's being used and then you could verify new ZK proofs that cover new functionality added to Ethereum or changes to the consensus protocol or whatever. With HBitVM, we don't have that, and so one of the things that we had to figure out from a ZK engineering perspective is how to do upgrades to the ZK system without having to touch the underlying configuration of the ZK verifier at all, and potentially be able to let that ZK verifier live for a year or 2 years, 3 years, completely offline, and then be able to come online when the vault's finally opened and someone actually withdraws liquidity from it. The BTC is fronted by an operator. The operator submits a ZK proof. How do we validate not only multiple years of ZK state in a single ZK proof, which itself is not that hard with recursive proofs, but how do we survive upgrades of the Ethereum network, the Hemi network, and theoretically also Bitcoin? And so the solution that we came up with that's in the white paper is a ZK bootstrapping system. So it's sort of a meta layer over the ZK proving components. So if you look at the stack of ZK proving from all the way down on the Hemi layer, all the way up through the Ethereum derivation, extracting Bitcoin data, then the pieces that we're doing with POP between Bitcoin and Ethereum for each of them to keep each other in check. All of that requires different ZKVM guest programs that each have their own image IDs. And if there's a change to any of those protocols, then those image IDs would change. So for example, if Ethereum does an upgrade in 6 months and adds a new opcode, then the EVM state transition, say Hemi adopts that update, then the EVM state transition for validating Hemi L2 blocks would need to be aware of that new opcode. So that's going to be a updated ZKVM guest program with a different image ID, different that you need to validate these new ZK proofs against. And so we have this meta layer that basically has all of the components that need to be, all of the ZKVM guest program image IDs programmed into it, and knowledge about the overall chain structure and relationships between them. And knowing that, we need Hemi blocks to be derived from Ethereum DA, and that's going to be this type of proof, and then that's going to give us this update to this intermediate state that we're calculating in this meta ZK guest program, and then we can use that to pull information about Bitcoin from HVM and then use that to validate the current Ethereum state, and then another ZK proof validated in that ZK meta layer to update now the Ethereum tip, and then we can do another DA derivation cycle from that, get new Hemi blocks, validate ZK proofs of those, extract more Bitcoin information. So it's this ZKVM guest program that runs in a loop and has just very basic knowledge about the types of proofs that need to be validated and initial configuration. And then over time, Hemi governance can approve updates to each of the ZKVM or the lower level ZKVM guest programs, so that then that bootstrapping meta ZK prover is able to, on the fly, as it proves, say for example, we launch HBitVM in say June, and then there's an Ethereum upgrade in August. Then the initial vaults that were constructed in June, their ZKVM guest program that implements this meta prover would start with the image ID for proving Ethereum chain segments as of the current state in June, but then Hemi governance would update it in whenever I said August that they update it. And so we'd have governance approve a new image ID update, and then the meta ZK prover, when you run it fully end to end to unlock an HBitVM vault, would be able to extract that update to the ZKVM guest image ID that it's actually validating from the Hemi chain, basically detecting that governance change as an emitted event, and then update the image ID that it's validating its own ZKVM guest proofs against for proving Ethereum state transitions. So I'd say that's probably the biggest open engineering challenge. We have a design for exactly how to do it, but that needs to be implemented, and it's not a brand new pattern in the space, but it is something that's relatively new and also specific to designs that need to be able to survive being offline for a long time and then being able to ZK prove a bunch of different chains together in a certain way where each of those chains protocols can update. Since we were last able to configure the ZK verifier program that's running, which is that Roth16 verifier in Bitcoin. So I'd say that's probably certainly the most technically interesting piece of it. Most of the rest is just scaffolding, plugging things together. Some updates to existing projects works for the Groth16 verifier on Bitcoin to make it compatible with our new proof format, which has a smaller statement of just the timestamp instead of additional data that it validates against. So there's minor tweaks needed there. And then building out the smart contract layer for that, that's relatively straightforward. It's just standard engineering of this data comes in here, goes here, we validate this data here, and then take this action there. So I'd say the biggest open, most interesting engineering piece is definitely that meta ZK prover. And then as far as total gaps, it's the finishing up the Oxygen ZK prover work, hooking that into existing EVM execution ZK proving systems that are already battle tested and production ready in the space. And then writing that ZK prover meta layer, testing that, getting that audited, and then contract upgrades and small tweaks on the Groth16 verifier side. And then minor things like changing the Bitcoin, the pre-generated Bitcoin transaction graph structure, but things like that are pretty trivial.
All right. Speaking of ZK provability, how do Hemi's approach to ZK proofs for Bitcoin state verification compare technically to what competitors like Stacks, Bob, or Citria are doing? Where do you think Hemi has a genuine technical edge versus a marketing differentiation?
It's a good question. So a couple different major areas. So the first is HVM. So the Hemi virtual machine, the full Bitcoin node embedded inside the EVM, basically lets you get access to far more Bitcoin state from a programmability perspective than you can get on any other chain. So most other chains that have some level of Bitcoin awareness either use the Bitcoin header relay approach. So this has been, I think the first version of this was launched like basically right after Ethereum launched. It may have even been in development when Ethereum was in testnet. And so the idea is basically you have relayers who relay Bitcoin block headers. You have a smart contract that validates their validity that they build on the previous block. They hash to a block hash that's under the correct target. Difficulty retargets are calculated correctly, so on and so forth. So basically the same lightweight consensus validation that you'd have for say a Bitcoin light client on your phone or something with SPB proofs. And then the only things that you can prove about that Bitcoin state against that header only view of Bitcoin is obviously metadata about a block that's contained in the block header itself, because that data is on chain, or that specific transactions do exist. So you can prove that the Bitcoin tip is this specific block, and you can prove that this transaction is in this block in the canonical Bitcoin chain. What you can't prove is you can't prove that a transaction does not exist. You could theoretically, but it's computationally infeasible. And so you basically need to bring all of Bitcoin data on chain in order to prove that a particular transaction doesn't exist. You also can't prove anything about the UTXO set. So you can, again, prove a transaction does exist and that a UTXO was created, but you can't prove that a UTXO has not been, or an output has not been spent and is thus still a UTXO at the current canonical point in the chain. And so things like looking at an address's balance, looking at whether a output has been spent or not, looking at some of the stuff that we're also adding to HVM in the next upgrade for fee statistics, things of that nature. Those aren't possible with a header only or a header relay approach. So part of it's the richness of the data that you can actually access. Now it is of course possible somebody could write a ZK proof system for Bitcoin that proves various things about Bitcoin and makes them accessible on chain. Part of what we're building is that, not to support HVM specifically, but to allow the features that we have in HVM to be ZK proven for overall ZK proofs of the network. But the problem with the pure ZK approach rather than the HVM embedded node is still that smart contracts can't dynamically access Bitcoin state. So they would need to have whoever's calling the contract on the EVM chain where this ZK Bitcoin awareness is implemented would need to bring all of the ZK proofs that are going to be needed for the contracts, branching execution on chain at the time of call, versus the contract during transaction execution being able to arbitrarily go through whatever Bitcoin state it needs. So, for example, on Hemi, if your contract needed to look at a certain UTXO, verify that it's unspent, and then walk backwards, 3 steps to check a previous address that funds had come from for some reason. Maybe you're building a system that does some lightweight on-chain verification that an address isn't on an OFAC sanctions list or whatever. Not a great example, but if you need that sort of robust ability to crawl through Bitcoin arbitrarily during execution, with HVM, you can do that because all of the data is actually there in the EVM. So the smart contract, as it executes, can say, oh, okay, now I need this data. Let me go get this transaction or check this UTXO or check this address's balance or get the outputs from that transaction over there, or walk backwards in the chain to next point and check this thing about that block. Whereas with a ZK system where you could get access theoretically to that same information, the person calling the transaction would have to first generate all the ZK proofs for that locally, which for most users of contracts that be using these proofs is infeasible. Just to give a little bit of context, the ZK proofs for a lot of our for the HVM precompiles themselves, they're pretty small, but the Bitcoin state transitions require somewhere in the order of 10 minutes to an hour on a high-end GPU, which again, not crazy, sort of in line with Ethereum ZK proving, but from building a user-facing application where the user generating the transaction needs to create those proofs and bring them on chain, that's pretty much an untenable design decision. And you could have, prover networks that a user submits a transaction, and then you have provers who trace through the transaction, see everything, all of the Bitcoin data that's going to be needed. They have specialized, computing hardware. They have, a rack with a bunch of GPUs in it. They generate the ZK proofs and then send an on-chain transaction that gives the right ZK proofs for the right Bitcoin data for that transaction to execute. That ends up creating a much more complicated DeFi app design. There's a lot more moving pieces that could potentially break, or where something could go wrong, or the relayers aren't active, so people can't use the system, or not relayers, but the ZK proof backfillers, if you will, aren't available or are delayed. They could withhold ZK proofs for a period of time to manipulate the system in sort of an MEV style attack against certain types of protocols. So having that direct access in the EVM to a fully indexed Bitcoin node that a smart contract can get whatever it needs from, and can, again, get any data arbitrarily as needed during execution, even if that data is not necessarily known at the time of transaction creation, or ZK proving that data would be computationally infeasible for average users of your DeFi app. That's why the approach of having the Bitcoin node fully embedded inside the EVM makes it a lot easier to design all kinds of new Bitcoin DeFi apps that you can't either do at all with other approaches, or can't do practically from actually delivering a working smart contract system that users can engage with and don't need, a GPU cluster in order to use your DeFi app. So super high level, that's the HVM side of writing Bitcoin DeFi, Bitcoin aware smart contracts, and how our approach compares to what other people are doing in the space. The other part is ZK provability. So this is more directly on the obviously the HBitVM tunnel side, but also some of the other cool use cases of BitVM style constructions that you can now do a lot more securely with our HBitVM proof system. So a lot of our competitors in the Bitcoin L2 space who are doing ZK provability and are doing BitVM style designs, either they are using the original Covenant emulation system that was proposed in the BitVM 2 white paper, which is fundamentally broken, miners can ransom attack it, or they've introduced workarounds to that superblock-like client emulation system. So they've introduced, say, a watchtower system, or some sort of way for a group of participants to establish canonical Bitcoin state in a sort of out-of-band mechanism that gets fed and validated in some way back into the BitVM transaction graph on Bitcoin that's being validated. And so they're either vulnerable to the superblock-like client emulation problem, or if they've worked around it, most of them have introduced more centralized solutions that either add more complexity to the protocol and or add permission parties who are responsible for doing more things beyond what the original veHEMI2 design wanted, and changing some of the trust assumptions, making it a little less permissionless and allowing new classes of participants to potentially manipulate the system in other ways. And then the additional part of that is the other BitVM style designs are not ZK proving. So one of the things that we cover in the white paper, if you want to read more about this, what we call the zero knowledge, nothing at stake attack issue, is that for if you're ZK proving things on, this isn't quite ZK nothing at stake, but we'll get to that in a second. So if you're a pure Bitcoin L2 and you have nothing to do with Ethereum, then all of your data, your only source of truth is Bitcoin itself. And so you get into, partly because of Bitcoin's lack of programmability, you get into this state where obviously the L2 can see everything on Bitcoin. Not that that's always hooked up, but any data that you need to get from Bitcoin into the L2, you can reliably get. But the same is not the case for the L2 back to Bitcoin. And so when you're ZK proving a only Bitcoin L2 that doesn't have any connection with any other network like Ethereum, like Hemi does, your ZK proofs of your L2, and again, this depends a bit on the chain architecture, and there's different ways to approach it, but the security generally collapses down to the security of the sequencing system for the L2 itself, because even if you're using Bitcoin for DA, you still run into the same sort of chicken and egg problem of you're proving data back to Bitcoin about Bitcoin itself, and Bitcoin lacks enough self-introspection to validate that data. And so as a concrete example, if you have a Bitcoin L2 and you're using Bitcoin for DA, which doesn't scale, but that's besides the point, then when you're, say you have a decentralized sequencing system that uses proof of stake on your L2, and you have a derivation algorithm that rederives the chain from DA publications to Bitcoin, then the issue you run into is your chain, the ZK proofs of your chain that you're returning to Bitcoin and validating as part of a BitVM system vault withdrawal, is that ZK proof has to demonstrate that not only is the L2 internally consistent, all the transactions in the L2 chain are valid, the withdrawal was attempted correctly, liquidity was fronted by the correct operator and detected by monitoring contracts on the L2 or however it's architected, but it also has to validate that the L2 was derived from a canonical Bitcoin chain. And since, again, Bitcoin can't see itself, you run into the superblock light client emulation problem in a different form, where the ZK proofs can prove that there is a L2 chain derived from a valid Bitcoin chain where the withdrawal was initiated correctly and the operator for that particular vault correctly fronted the liquidity. You can't prove that that's on the canonical Bitcoin chain. And so, again, there's workarounds, but those introduce new permission sets of users or operators or other design trade-offs that change the original trust model of the BitVM2 design. Whereas with Hemi, what we're doing is we're connected to both Bitcoin and Ethereum, and so we can use each of those networks to basically keep the other one in check. And so this is where I was getting to zero knowledge, nothing at stake attacks. So on the Bitcoin, there's no way to establish in a ZK proof the true canonical state of Bitcoin if Bitcoin's all you have to look at. If you have an external additional secure coordination layer like Ethereum, then you can use that to allow anyone to permissionlessly relay Bitcoin information, Bitcoin consensus information to Ethereum, or in our case, through Ethereum to the Hemi chain. And that basically acts as this censorship-resistant external observer Bitcoin consensus. And so as long as there's one honest participant, which is in line with the original BitVM2 trust assumption model or trust model, then anyone can relay any known information about canonical Bitcoin state. You can quickly establish what is the actual true canonical chain just by header-only consensus and canonical checks. Obviously, we have the full HVM embedded Bitcoin node that also validates that Bitcoin state is actually completely valid, not just valid from a header consensus perspective. But using that system, we can now leverage Ethereum as this anti-censorship layer for establishing true canonical Bitcoin state. And then the ZK NAS problem is Ethereum itself uses proof of stake, and especially for a long offline verifier, it's somebody could get old keys of Ethereum validators from say 2 years ago if the HBitVM vault was created 2.5 years ago or whatever. They could get old keys that are more recent than the HBitVM vault's construction, but still very old and potentially no longer with any funds that are active in the network and potentially slashable. And the attacker could use that to create a fake version of Ethereum state that has a fake version of Bitcoin consensus, and then use that to create invalid proofs that look valid. They meet all of the validation rules of the ZK verifiers because you have a valid internally consistent Bitcoin chain, a valid internally consistent Ethereum chain, and transactions in that Ethereum chain that establish that the canonical Bitcoin state is this fake Bitcoin state that you're claiming. And so to prevent that, what we did is we upgraded, or we are upgrading the proof of proof publication system to basically publish enough information from Ethereum to Bitcoin to ensure slashability. So basically the attestations that get created by Ethereum validators in order to finalize Ethereum state, those attestations are super compact. It's basically a aggregated BLS signature and a bit field of participants. And if you publish that data to Bitcoin, then there's enough data on Bitcoin to slash any validators who create an alternate Ethereum chain, whether it's a nothing at stake attack or not. But then the important part for nothing at stake attacks, where you get again old keys from 2 years ago or whatever, is that we can add a validation rule that only allows a you can create a rule where advancing Bitcoin state and advancing Ethereum state have to be done together. And when you advance the state of the Ethereum chain, it can only advance so far from a timestamp perspective ahead of the currently known Bitcoin chain in that meta ZK verifier. And it can only advance if recent attestation data from that Ethereum chain is published to Bitcoin within a certain timestamp window of, currently it's probably going to be set to either 24 or 48 hours, something in that range. You can make it a bit longer to prevent, some crazy Ethereum event from causing liveness issues, but that's besides the point. And by doing that, you basically made it so that if an attacker wanted to create and forge a malicious version of Ethereum, they would have to publish enough information about Ethereum to Bitcoin while their stake is still active. So, taking the 2 years ago keys example, it'd be impossible to take old keys and generate this new chain because the proofs of your chain from the last 2 years would not be in the actual canonical Bitcoin state from the last 2 years. Or if you were going to pre-plan this attack and generate this, alternate Ethereum chain at the, in relative lockstep compared to actual wall time with the true Ethereum chain, then, with the true Ethereum chain and with the true Bitcoin chain's progression, then you'd be publishing enough information while your keys are still fully staked on Ethereum that then you could be slashed. And so we use Ethereum as this anti-censorship layer to establish true canonical Bitcoin consensus without needing any sort of permission party to do so. Then we have this zero knowledge, nothing at stake issue with Ethereum that we then use Bitcoin to solve using these new pop publications of Ethereum attestation data. So the end result is basically somebody who wants to attack the system and create invalid proofs. They would need to hold the majority or supermajority of Ethereum consensus power. That's a security and liveness parameter trade-off for the instantiation of the HBitVM proof protocol. And they'd also need to 51% attack Bitcoin, or at least control 51% of the Bitcoin hash rate as of the time of the establishment of the HBitVM vault they want to attack. So if the HBitVM vault they want to attack was created when Bitcoin's difficulty was at, 1 quadrillion, and then it goes to 1.2 quadrillion over the next 2 years, they would need 51% of the original 1 quadrillion value equivalent in hash rate, and they'd need to expend that over a period of 2 years in order to create that malicious proof. So essentially you have to 51% attack both networks, and that also creates a system where nobody can manipulate Bitcoin state and reflect a incorrect version of Bitcoin state unless an incorrect version of L2 state back to the ZK verifier on Bitcoin that allows you to withdraw funds from, that allows the operator to withdraw funds from the HBitVM vault. So to summarize all of that, basically from a pure programmability perspective of you want to build some cool new Bitcoin DeFi, Bitcoin aware app, HBM gives you the most flexible way to do it because you have direct access to Bitcoin data. You don't need the user initiating the transaction to feed in anything about Bitcoin other than, if they want to do something with a specific transaction, obviously anything specific to their transaction that they're sending in, they would send in, but you don't need them to relay any consensus information. You don't need them to relay any ZK proofs of Bitcoin state. And then the contract can dynamically, during its execution, look at whatever Bitcoin data it needs, use that as a, whatever branching logic it has. If it needs to get this transaction, this UTXO, whatever, it can do that all dynamically. And then from the tunneling perspective, or the use of HBitVM style technologies for other things like Bitcoin-backed stablecoins, Bitcoin-backed lending protocols, native Bitcoin settled derivatives products, all of those can use these HBitVM proof system proofs, which are secure against manipulation using a combination of a majority of Ethereum and a majority of Bitcoin consensus powered together. And so that makes the overall system much more secure from a ZK proof generation perspective. So protection against forging ZK proofs that claim to prove invalid Bitcoin and invalid L2 state. But it also lets us remove any sort of centralization trade-offs in the HBitVM protocol design that would normally be needed to establish that canonical Bitcoin state to validate the ZK proof against. So the end result is a ZK proof coming out of the HBitVM proof system can be validated just against a timestamp, which you can do on Bitcoin. There's a little bit of a trick to doing it, but you can do it securely on Bitcoin without needing any sort of out-of-band agreement on current Bitcoin state or current timestamps or anything like that. And anything that you prove about the Bitcoin, Ethereum, or Hemi chain states that are authenticated by that ZK proof are valid as long as the timestamp in the statement of the ZK proof is within a certain distance of the actual timestamp of the chain in which that proof's being validated. So it also has a lot of cool knock-on effects for just secure ZK proofs of Ethereum in general, even beyond the Bitcoin ecosystem. But obviously the part we're most interested in is how you can use that together with HBM to establish secure proofs of claims about Hemi state and claims about the Bitcoin state that HBM has a view of from the smart contract layer.
All right. Let's see. Here we go. For the institutional custody compliance angle, now prominent in Hemi's messaging, what specific regulatory frameworks or compliance standards, uh, compliance standards has Hemi been evaluated against? And are there any formal legal opinions or regulatory engagements the team can point to?
So at the moment, we don't have any formal compliance audits from standard compliance frameworks of that sort. We're following industry best practices for fund security, and we are in talks with multiple different institutional grade custodianship providers to shift custodianship over to them for the entire system. And again, this is only the design for now until we launch HBitVM, where the entire idea of custodianship goes away and it's all completely end-to-end ZK secured. So at the moment, industry best practices, we routinely do internal security reviews. We do pen testing against certain infrastructure. We have a lot of mechanisms and checks and balances in place on our side, but it doesn't line up with any sort of formal compliance standard you might see in more traditional Web 2 environments. It may change in the future, but that's the current state.
All right. Let's see. Did you know Hemi's proof of proof system would solve these ZK problems when it was originally conceived?
No, so that actually the original proof of proof system doesn't solve this issue with ZK proofs for zero knowledge nothing at stake attacks. But it was a very exciting discovery as we were thinking through how to, okay, we can use Ethereum as this anti-censorship layer to establish Bitcoin consensus, great. But Ethereum itself has this nothing at stake problem. So what we figured out was we can expand the proof of proof system. So it's the same general DNA of, decentralized incentivization of publication of one chain state to another in order to, air quotes, secure that chain, right? The original POP design was about securing, one chain, a security inheriting chain to a security providing chain. So securing a chain like Hemi to a chain like Bitcoin, and then being able to use those publications for fork resolution to determine the canonical version of the underlying chain. And then with this new expansion of proof of proof, it's again the same general idea, but instead of being used for fork resolution and finalization, Bitcoin finality, it's being used for preventing somebody from creating a unknown fork of a chain using Bitcoin. So being able to make sure that nobody can forge Ethereum state without having to publish enough information about that to Bitcoin for it to be evident that somebody's doing it. And the new part of the protocol, which is publishing enough data about that private fork to Bitcoin in order to actually be able to slash the validators who misbehaved and created that private fork. So with something called early attack detection, it was always possible to just look at the pop publications of a chain's, consensus state to Bitcoin or whatever security providing chain, but in all realistic cases, Bitcoin, and see that somebody was creating a malicious chain. But with this new upgrade now, you'll be able to have enough information about that chain to slash the validators who created that malicious private chain as well. And so that was the sort of the protocol improvement, the new unlock that let us reuse POP and basically expand it out to protecting against zero knowledge nothing at stake attacks.
All right. And I believe we have time for, yep, we have time for one more question. Remember when I said this would be the shortest episode ever? Well, then you guys got Max talking about ZK provability, and that went right out the window. So,
Always happens.
always happens. There's all right. What does Hemi think about MEV on its network? With a centralized sequencer today, who captures MEV? And what's the plan for MEV distribution or mitigation once sequencing is decentralized?
Just add first, Hemi is a chain, so hopefully Hemi doesn't think anything.
That is fair. Hopefully, Hemi does not become sentient. Then we have bigger problems to worry about.
We would have a lot of problems if it ever became sentient.
From an MEV perspective, so right now with a centralized sequencer, there's no MEV logic at all. So transactions on the sequencer are ordered purely in the order that the sequencer hears about them. Obviously, that's a trust assumption that we're actually implementing that logic correctly. You can, for the most part, verify that that's the case by looking at transaction propagation in the mempool and comparing that to block inclusion. Obviously, your view of the mempool could be slightly different than the sequencer's view because there's multiple nodes on the Hemi network, there's RPC providers, and so stuff propagates across the network at slightly different times to slightly different observation points of the network. But at the moment, there's no MEV extraction logic. It's just purely order of transactions that come in, make sure they're valid, put them in a block, mine the block, start on the next block with more transactions based on the order they come in on. Obviously, subject to meeting the base fees and other validity requirements of transactions on the network. If they're above the relay base fee but below the current network base fee, they're obviously stored for inclusion in a later block. So there's some caveats there, but basically first come first serve for all valid transactions. As we decentralize, that gets a lot more difficult. So we We do have some ideas for designs that would allow more of a native on-chain MEV experience, that being basically taking major ideas from things like flashbots and enshrining them in the protocol. There's some also proposals for how to do versions of this on Ethereum. Our idea for it is using a predicate system, so being able to wrap a transaction, at least in air quotes. There's ways you can do it without changing the transaction format, but metaphorically wrap a transaction in execution predicates. So being able to say, this transaction can only be valid if it's at this position in the block, or you already see some of this obviously with things like Uniswap, where you set the minimum amount of funds you're willing to receive for the transaction to execute correctly. You can expand that to a predicate system on steroids that can be used to define a lot more characteristics about the transaction's inclusion in the chain in order to be considered valid. And with a protocol change, you can enforce that instead of just at the EVM level, you can enforce that at the block validity level. So you can say, on Ethereum, you could do something like if a transaction is, not in a certain block, then block execution, but the transaction can still be executed, it just doesn't actually do what it was meant to do on chain. Whereas if you enforce things like that at a protocol level, then you give people more flexibility to design transactions that say, this transaction is only valid if it's in the next block. Transaction is only valid if it's in this part of the block. One of the other potential design, I wouldn't say solutions, but ways to address and mitigate MEV is with pre-confirmations. So you can have sequencers commit cryptographically to including a certain transaction at a certain point in the chain. And so you could have, if you combine that with the protocol enforced predicate system, you could have a transaction environment where people could specify, I want this transaction to execute. I am willing to pay extra for it to be the first transaction in the block itself, and it has to be in the very next block to be valid. And if you're paying a high enough fee for that, a sequencer will be willing to pre-commit to putting your transaction at that position in the block, and then you can enforce that rule cryptographically and cryptoeconomically by having the sequencer sign a pre-commitment, and then if they violate that rule, the protocol could, or for the predicates baked into the transaction itself, the protocol could reject the block for including the transaction in the wrong place or in the wrong conditions. But also from a cryptoeconomic perspective, if they did include the transaction and it then failed due to its predicates being hit, and so it executed on chain, but it didn't actually do what it was supposed to do, then the person who initiated the transaction has the pre-commitment proof from the sequencer that then they could bring on chain to slash the sequencer for a large amount of their staked veHEMI position, and a portion of that would go to the user whose pre-confirmation from the given sequencer wasn't respected. There's also some things you can do in the way that you allow dynamic block construction. And so right now, Ethereum blocks are monolithic. It is just a block with a bunch of transactions in a certain order. And external services like flashbots can do certain things that allow for configurability of where a transaction lands in the block, where they can segment parts of the block out in some very limited ways. But if you enshrine two separate sections, so one of the issues with MEV markets is the way that they currently work with the design constraints of Ethereum's current protocol implementation is that if you have an MEV service like flashbots, they can have a network of builders who build blocks, and they can competitively bid in an environment that allows the sequencer who's going to create the next block to choose the highest bidder's bundle of transactions and include them. But there's I don't know the right term, but there's a balance of power issue between the verifier or the sequencer, the validator, and the block builder, where the block builder, if they were to reveal their block bundle, in most cases, that would allow the sequencer to potentially steal their proprietary transaction ordering and even reorder the block and MEV attack the builder themselves if the builder is providing liquidity to do certain things. And so the block builders generally don't want to reveal their blocks until a verifier commits to using their bundle instead of another builder's bundle. But if the verifier commits to using a particular bundle, they're committing blind without knowing that the bundle is actually valid. And so you have this problem where a bundler or a batch constructor can build an invalid block and then can basically grief attack Ethereum operators, and systems like Flashbots have, off-chain, and I'm no expert in the details of Flashbots, but presumably, semi-centralized mechanisms for punishing parties that, punishing a batcher that produces an invalid batch that's not going to execute it, goes over the gas limit, or has a invalid transaction or whatever. But you can enshrine, if you enshrine certain things about block format on chain as part of the protocol, then you can make that system a lot easier to build in a decentralized, secure manner. So one solution to that problem without protocol changes is ZK proof. So you could have the batchers construct a ZK proof of valid execution of their block or of their bundle of transactions, and supply that to the validators actually creating the block. That's one way, but the problem is you need to construct ZK proofs very, very quickly, and it also centralizes power in the hands of the block builders themselves, because they would need very expensive, sophisticated ZK proving hardware to be able to effectively do real-time Ethereum ZK proofs, even better than real-time, because you have a period of time where you need to observe transactions on the network, and the more time you have to observe transactions before building your bundle, the more MEV you can extract, but then the shorter of a time you have to actually ZK prove it. So it basically centralizes to the one single batcher with the fastest ZK proving hardware wins the auction almost all the time, because they're able to wait the longest and build the most competitive block that they can ZK prove. That's not a great solution. But if you enshrine certain designs around the block format on chain, you can make that system a lot more decentralized and robust. So you can have basically a reserved section of the block where a verifier can include a bundle that to them is opaque until they actually sign the block and commit to including that bundler's bundle, at which time it's revealed. And the protocol can allow that bundle area to be invalid, but can also allow, or partially valid, but can then allow a separate section of the block where, say, validators give pre-commitments to specific transactions that run before anything from the MEV bundler system to be run regardless of the validity of the bundled section of transactions. So basically, that removes the griefing vulnerability where a bundler can create an invalid bundle and get a verifier to commit to it. The only thing the verifier loses in that case is the fees that they would normally collect from executing the transactions. But you can solve that by having the bundle come with a on-chain enforced payment from the bundler to the sequencer. And so the sequencer, the block generator, knows that regardless of the validity of the transaction bundle they're blindly committing to, they'll get paid X amount. And so that can be used to largely solve that problem. And then because you have the separation of the pre-commitment section against the MEV bundler section, and you have the pre-commitments execute first, the sequencer can engage directly with transaction submitters to negotiate on transaction ordering in a way that's cryptographically enforceable on chain with penalties, and then also allow a MEV marketplace to exist that doesn't jeopardize block validity. So is all of that going to be part of V1 when we decentralize the sequencer? Almost certainly not, but those are the current design ideas we have for how to make MEV both more egalitarian, so you don't get the centralization around a particular MEV marketplace or particular bundlers in the MEV marketplace, and also allow for block structure that's more compatible with things like pre-confirmations and other direct user to sequencer engagements, while not making it a one or the other choice of either doing pre-commitments or engaging in an MEV marketplace as a sequencer. So high level, there are definitely solutions. None of them are perfect, and there's always going to be MEV opportunities where because you're executing transactions in an EVM, and the execution of one transaction depends on the state of the EVM that gets mutated by other transactions, there are always going to be opportunities where MEV can be exploited. The only ways to truly solve that require introducing centralization again, which is not the end goal of decentralizing sequencing. But there's a lot of things you can do to mitigate it, especially for more advanced users who are willing to engage with things like pre-commitments or certain types of MEV marketplaces that, again, can be more open because of this more MEV-centric block design that separates out different parts of the block for different purposes and doesn't predicate entire block validity on bundler validity.
All right. Thank you so much for that. Let's see. Oh, yeah. As creator pointed out, I lied when I said this would be the shortest midweek with Max ever because, as always, we have run over time. So, well, what are you gonna do? But yeah, that is our time for this week. I apologize we couldn't address every question. Sorry for the time difference for folks who joined a little late. We do have stupid daylight savings here in the U.S. still for some godforsaken reason, so that may have thrown folks for a loop. But I just want to thank everyone for coming out this week. Apologies again for the questions we didn't get to, but we will be able to address them next week. Let me turn it over to Max for outros, and we will see you all on Discord. Oh, before I do, please remember there is a moderator-led activity. I believe it's GeoGuessr happening directly after Midweek with Max. So without further ado, here is Max and team for outros, and I will see you all soon.
All right, awesome. Thanks everyone for coming to another Midweek with Max. Again, apologies on the daylight savings time if there was a issue with the scheduled event time mismatching with start time. So thankfully that only happens twice a year. So next week we will be back on regular schedule with events scheduled at actually the correct time. We are also, as I mentioned earlier, planning the AI happy hour probably for Thursday. So time TBD, but we'll announce that shortly as we finalize the time that works for everyone. Also, if you missed it and you're interested in even more of a deep dive in ZK provability and both in general and what Hemi's doing with ZK proofs and some of the interesting ways that not only contributes back to Hemi's overall design, but also could be used in interesting other ways in the broader blockchain ecosystem. Definitely check out the ZK AMA we did on Friday, which you can find on X, YouTube, and I believe LinkedIn. So if you're interested in more of a ZK deep dive than we've done today or previous midweeks, that's a great resource for that. And other than that, definitely stay tuned for some cool stuff we'll be shipping for testing soon. The first one probably being the ZK Proof Marketplace. And so if you're not in the beta testers channel and you want to participate in that and get some Hemi token incentives for doing so, definitely join us there. And with that, we will see everyone next week.
All right. Thank you to Max. Thank you to the team. Thank you to our community moderators. And thank you to the community in whole. Thank you all so much, and we will see you next week.
All right. Cheers, everyone.
Take care, guys.